Alright, this is a simple circuit. We're going to find out all the different particulars for this circuit. So we want to start with the resistance total. Okay, to get resistance total we need to get the parallel resistance of these two, then sum it with the series resistance of this one. So we'll start with getting the resistance across these two, the combined resistance. Now to do that, that's the formula. Okay, so 1 over 1 over 1 over plus the 2. That's going to equal 3.333 ohms. Plus we want to add the 5. That's going to equal 8.333 and so on ohms. Alright, we're going to get the current total. So that's going to be 10 volts over resistance, the resistance total. It's going to equal 1.2 amps. We all following along. Right, we want the resistance, we want the voltage that's dropped across R1. So we'll go call it V1 equals IT multiplied by the 5 equals 6 volts. So we know 6 volts is dropped across this. So logically that would mean V2 equals 10 minus 6 equals 4 volts. So this is 4 volts. Okay, so we've got 1.2 amps here, 1.2 amps here. If we don't have 1.2 amps here, we have a portion of it. Alright, so we're going to go for the I, we'll call this I2, we'll call this one I3. I2 equals 4 over 10 equals 0.4 amps. So this is 0.4 amps. I3 is going to be 4 over 5 equals 0.8 amps. So this one equals 0.8 amps. Okay, so now we want to get the voltage across, now we want the power across each of the resistors, and we want the power total. So power total equals V times I equals 10 times 1.2 equals 12. So the sum of all the wattages should equal 12. Let's try that. So P1 is here, equals 6. Remember it's 6 volts across here. 6 times 1.2 equals 7.2 watts. P2, so we'll call this P2, equals 4, because remember that the voltage here is 4 volts. 4 volts times 0.4 equals 1.6. P3, so P3 is here, equals 4 times 0.8 equals 3.2. Sum them up, you get 12 watts. That's them all. Hit that like button, hit that subscribe button if you want more of these easy tutorials.